So, hello everyone, welcome you all to AIG Pathsala, and this is Anup Jha, your instructor, and I'm starting a new series of machine learning. So here, what we will be we will be doing from the very scratch, from the very basics of the machine learning to the various advanced machine learning. At the end of this whole machine learning concepts, we will also be doing a machine learning projects. So it's very good for all of you. So if you want to, this is a free community session for me, and I will also be uploading this video on the YouTube. So any one of you who are interested to study free of cost, you can follow my channel. You can go to my LinkedIn. You can come to my Telegram or my Facebook community. There you can join and avail the benefit of completely free machine learning course, absolutely free at nothing, at no price at all. This is a kind of community service from my end. Fine. This is a kind of contribution from my end, from all of you. So let's start. आप लोग को मेरा स्क्रीन दिख रहा है? कैन यू गाइस प्लीज कंफर्म मी कि आपको मेरा स्क्रीन दिख रहा है या नहीं?
कंप्लीटली ब्लैक।
ब्लैक? हाँ, मतलब मेरा बोर्ड दिख रहा है ना, क्योंकि वो
बोर्ड
ब्लैक ही है, तो डेफिनेटली ब्लैक ही दिखेगा आपको। मतलब मेरा यही पूछने का मतलब था। एंड अभी आप बता सकते हैं आपको क्या दिख रहा है? हेलो? ठीक है, सो हम लोग स्टार्ट कर सकते हैं सर। आर वी गुड स्टार्ट? बीच बीच में आप लोग मुझे अगर किसी को कोई डाउट्स रहता है, इफ सी इफ एनी वन ऑफ यू हैव will be having any doubts, you can just unmute yourself and ask your questions. So we will proceed like that. Varun, are you there? Can you take quick yes or no from your end, Varun? Are you guys able to see my board, what I am writing?
yes, but nothing can be seen. Yes, I can see you are writing something. Dimensional T.
That means it is visible. You people are able to see.
Yes.
Can all of you confirm me? Rakesh, Varun. Can you please unmute yourself and confirm me once?
Yeah, I can see.
ठीक है, ठीक है. So let's see, actually machine learning, when I'm starting the machine learning, usually what happens is that people used to teach the algorithm first. Algorithm first. But here I will be following a very different approach today. So what approach I am doing, I will be first teaching you about the dimensionality reduction technique. This is something called dimensionality reduction technique. So first of all, the question arises, why we are studying this dimensionality reduction technique? So we are studying this dimensionality reduction technique because we are using the application of this we are using in machine learning. That's why before going to the actual machine learning algorithms and learning about its mathematics, we will be studying about first the dimensionality reduction technique. Fine. Now, what is this dimensionality reduction technique, and why we will be learning this dimensionality reduction technique? So basically, this is called, first we will learn what is dimensionality reduction technique. What is dimensionality reduction? This is the first thing that I will be covering. And the second thing that I will be covering, that why should we learn it? Why should we learn it? Fine. So this is the second thing. Now, see, if you have seen a data, let's take an example of some data. So here I am taking an example of a data just to make you understand the things. Fine. Let's say I am taking the student data. Let's say this is student 1, this is student 2, so on and so forth. There are n number of students. Student n. This is just the name of the student. This is the name of student. This is, I am giving the name as 1, student 1, student 2, student 3, so on, so forth till student n. And here there are certain, and these students are, let's say, are studying in some college. Fine. So there are some features of these students that I want to address here. So let's say a student have a name. This is a student. Every student has some roll number. Every student will study some kind of course. Let's say every student is studying some course. Every student has some certain specialization. So let's say I am giving this column specialization. Likewise, let's say, let me give me from your end, let me give me few features that I can write here. Can you give me any features that you want me to include here? Any one of you? Every student, let's say I'm giving you, every student has a mobile number. So give the mobile number. Likewise, I can give certain number of features, certain n number of features. So this kind of data, where there is every student, I am taking this. If I can take this student 1, I can say this student 1 has these number of features. The student has certain name, some name. The student is having some particular roll number, unique roll number. Student is pursuing some kind of course. A student is also pursuing some kind of specialization inside that course. A student is having some mobile number. A student, let's say you can also write, students will be scoring certain marks. Likewise, there are n number of features that a particular student is having. Now, if you look at this table, this is a row. This is my row 1. This is my row 2. This is my row 3. Likewise, I can have n number of rows. Row n. And this is my column. This is my first column. This is my second column. This is my third column. This is my fourth column. So on and so forth. There are n number of columns. Now, if I tell you, let's say this student, I'm having a data of a student in which these are the rows. Rows is inside this rows. I'm having this name of the student, and every student has these many number of features. And there are n number of features. So there arises a question, how I can represent. This is a tabular representation. In the form of table, I have represented it. But in terms of, if I want to plot this data, how can I plot it? Fine. So just keep this thing in mind. Again, we will come back to this thing in few minutes. Now let's understand something else. So I have already covered. If some of you have not seen, you can go to my YouTube channel, AIK Pathsala. There is a playlist called Exploratory Data Analysis. Short form is EDA. There I have covered these things in very details. Here also I am going to discuss a little bit so that for your understanding. So if some of you who have already seen it, if you recall it, so in exploratory data analysis and plotting, we have learned something about called 2D plot, and we have learned something called 3D plot. So, and there are certain plots which are called 4D plots, 5D plots, 6D plots, or you can say till 6D plot we have given. So what we have studied, to represent the data which is a 2-dimensional or 3-dimensional, we used to represent it with the help of scatter plot. So there's a plot called a scatter plot. If you recall, this is something like, let's say this is some X, this is some Y, and these are some points. So each point is having certain value of X and Y. This is a kind of scatter plot that we have already studied. So to represent this 2D data, for 2D data, we use 2D scatter plot, and for 3D data, we have used 3D scatter plot, in which Z-axis also K. This is my X, this is my Y, and this is my Z-axis. Fine. So we have represented, let's say, some data in the 3-dimensional space. Apart from that, but let's say if I have a data which is more than 2D, so we have conveniently saw that we can understand 2-dimensional data and 3-dimensional data with the help of scatter plot. We have already discussed. And for the dimension which is higher than 3D, that is 4D, 5D, till 6D, we have seen that we can use a plotting technique called pair plot. And we can calculate this, how many pair plot we can form with the help of this formula. There is one formula, NC2, where N represents how many dimensional data it is. Let's say if I took 5-dimensional data, my NC2 value will be 5C2. This is 5 factorial by 2 factorial into 3 factorial. So this is something 5 into 4 into 3 factorial. Mathematically, this is 2 into 3 factorial. I can cancel this out. This is 2 to 4, 10. That means total there are 10 pair plots. And with the help of this pair plot, I try to understand the relationship between the different features of the data. This is what we have talked about. But what about a data which is, let's say, 10-dimensional space, which is in the 10-dimensional space? or which is having a 10 features. In machine learning, dimensionality means the number of features a data is having. Just to understand you, I am telling you, let's say, what if I am having 100 dimensional data, or let's say I am having 1000 dimensional data. So in this case, this pair plot fails, because pair plot, we can conveniently use the pair plot and we can understand the relationship between the different features in a data with till 6-dimensional data only. Beyond that, it is not convenient, or it is not feasible actually to understand the data. So what about the data which is in a higher dimensional space? Now, when I am telling the higher dimensional space data, I mean to say features of the data. If a data is having 10 features, 100 features, or 1000 features, in that case, what is my solution? Because the human eye is only able to see the data which is in the 3-dimensional space. Beyond 3-dimensional space, human eyes is not equipped to see the data. So we actually visually we can't see any data which is beyond 3D. But we need to find out a way to understand the relationship between the data in the higher dimensional space. So what this dimensionality reduction technique gives me, with the help of this dimensionality reduction technique, I will be able to reduce the dimension of the data. Dimension of the data which is in a higher dimensional space. That is, let's say, n-dimensional space. I am telling n-dimensional space. Fine. This is the purpose of studying this whole thing, this whole dimensionality reduction technique. So now let's see so in dimensionality reduction technique, what we actually do, we use to reduce any higher dimensional data in either 2D or in 3D. How we will do it and how to retain the features, these all things we will understand. So how we do this, how we follow this whole dimensionality reduction technique, it all depends on what we want to preserve. So let me write it. It all depends on what we want to preserve inside my data. Preserve inside my data. Now, we will look at a couple of very interesting techniques. And these techniques are called, the first technique is called principal component analysis. Let me write it. Principal. I most often confuse in principal of a school and this principal. Principal component analysis. And the second technique is called redistributed stochastic neighborhood embedding. So let me write it. Redistributed. Let me choose this thing. Okay. Redistributed stochastic neighborhood embedding. Neighborhood embedding. Fine. So one thing that I want you to tell, don't panic with these fancy words, names. They are actually very simple, and we will go over both of these techniques. And these are very interesting ideas of dimensionality reduction techniques. So inside the dimensionality reduction technique, inside this dimensionality reduction technique, there are basically two techniques. One is principal component analysis, whose short form is TCA, and this is called t-SNE, t-SNE. The short form is this: redistributed stochastic neighborhood embedding is also called t-SNE. So this PCA is basically this PCA is very old technique. Old technique. Let me write it to reduce the dimension of the data. And this t-SNE is almost I can say state of the art in visualizing. This technique is, I can say, state of the art in visualizing high dimensional data. High dimensional data. Correct? Now, we will understand both of these techniques. Fine. And in this whole thing, we will actually visualize 784. I will practically show you, and we will visualize 784 dimensional data. Dimensional data. That means a data which is having 784 features. So why I will do this? Because just to give you a flavor of the type of problems we are trying to visualize, and the visualization that we get with PCA and this t-SNE, they are going to be I can say very terrific. So excited to learn about this dimensionality reduction technique, because when I remember when I first learned about these ideas like t-SNE, I said, wow, what a brilliant piece of mathematics. Though I can visualize extremely high dimensional spaces, but this technique is actually a marvel. So let's move ahead and let's proceed further. And before that, we also need to learn some very important concepts inside this before actually proceeding to before actually we will learn this PCA and this t-SNE. So the next concept that is there is called, next thing is called row vector and column vector. So now let's understand what is this row vector and column vector. Column vector. Fine. So in linear algebra, whenever we are given any data points, for example, let's took the case of the iris flower data set. If some of you have not be aware or familiar with this iris flower data set, so let me tell you, this is basically the collection of certain type flowers called iris flower from the iris family of flowers. And this is a kind of data set which is very readily available anywhere. If you Google search it, this data set is available with you. So what is this flower is all about? So for this data set, what does this data set gives me? It basically gives me for any given flower, for any given flower in the entire world, I can tell you, we are given 4 features, or we can say 4 variables. We are given 4 features, or we can say we are given 4 variables. And what are those 4 features? The 4 features Okay, Varun, do you have certain questions?
Sir, can you please just repeat this? Actually, the network issue has occurred.
Okay, what is the question that you are asking? Please, can you please tell me what you want me to repeat so that I can
So
repeat?
that the starting of that, the row vector, eight column vector, actually from that time. That's I don't forgot.
Acha, you are Varun, na?
No, I'm the
Okay, you are Divya. Okay, fine, fine, Divya. See, I will be explaining you this row vector and column vector in a while. But before that, understand this thing because I have not yet explained you this row vector and column vector. I have told that there is something called iris flower dataset. This is a kind of dataset which is very readily available in the whole internet, or if you can go to this mm, uh, anywhere inside this, there is one. You can Google it and you will get this dataset. Now, what I'm telling you, what this dataset is all about. This dataset, ये जो dataset है, ये flowers के बारे में. तो कोई भी any given flowers is having the four features, or I can say four variables. चार features होते हैं, चार variables. And what are those features? The features are sepal, length.
So,
Fine.
this is what is flower here?
Okay.
That normal जो हमारा फूल होता है वो वाला या something
वो
like
if you take any flower, आप कोई भी फ्लावर ले लो, फ्लावर मतलब फूल जो हम भगवान को चढ़ाते हैं, और
yes,
और हम कई बार खुद भी सूंघते हैं, कई बार लोगों
yes,
को
yes,
गिफ्ट भी देते हैं बर्थडे पे,
yes.
फ्लावर्स लेके या स्पेशल ओकेजन पे देते हैं, वही फ्लावर्स की बात है, ठीक है।
Okay, sir.
किसी भी फ्लावर्स में क्या होता है कि उसके चार फीचर्स होते हैं। वो फीचर्स क्या है वो मैं लिख रहा हूं, सेपल, लेंथ, सेपल, विड्थ, पेटल लेंथ एंड पेटल विड्थ। ये चार फीचर्स, इसको शॉर्ट फॉर्म में हम लोग लिखते हैं SL, सेपल लेंथ, सेपल विड्थ, petal length and petal width. These are the four features of any given flower. Now, depending upon the features, what is the value of this sepal length, what is the value of this sepal width, petal length, and all these four is having certain value. If you take any flower and measure these four parameters, the flower sepal length, sepal width, petal length, and petal width, you will get some value. Let's say, let's say this is 2.3. This is some random value that this is 5.6. This is, let's say, 1.2, and this is, let's say, 3.1. This is certain random value. Now, depending upon the value of these four terms, already there's some established researchers have already established, you can classify the flowers into one of the four categories called setosa, versicolor, virginica, and setosa, versicolor, virginica, and there is a fourth features that is called, and can you, any one of you, remember the fourth feature? What is?
It's one of the petal width.
No. Depending upon the four features, you can classify a flower into one of the four categories of the flower. The first category is called setosa, versicolor, virginica, and the fourth flower is called, there is what is the fourth name of the feature? Varun, can you please tell if you are present? What is the fourth flower? Okay, fine. So not an issue. There are 4 flowers, Setosa, versicolor, virginica, and there is certain, I do not remember the name. So we will come back to it later. But just understand, depending upon these 4 features, you can able to classify the flowers into one of the 4 categories of these flowers. Fine. Now, so given any data point like this, so I was there to explain you row vectors and column vectors. Fine. So now let's understand what is this row vectors and column vectors. So let's say if I take any flower here, you have, if I take any flower, so this flower is having 4 features: sepal length, petal length, sepal width, and petal width. These are the 4 features. And these are basically the real values. These are real values. Fine. Now, if let's say here, when if I write the ith data point, so inside this flower, if I let's say consider some ith data point, ith point, so what will be? I am writing it when I say ith data point as xi. So if I want to find the ith data point, I am representing this ith data point as xi. Xi is a dimensional, is a n-dimensional vector. So a dimensional vector which is having this R D. And what is this? This is basically d-dimensional D. Let me write it in different color. This is basically d-dimensional column vector. Column vector. So here xi belongs to RD. RD is basically real value with n-dimensional column vector. So I can say, let's say if I want to represent this thing, I can say this is basically my xi1. If I write it like this is my xi2, this is my xi3, so on and so forth till let's say xit. And this representation is called column vector. This thing, this R means real space or real values. This means real values, or you can say real space. Fine. And here, this is called D into 1. Why this is D into 1? Because we have, this is my first row, this is my second row, this is my third row till I have dth row. So this is D into 1 and I have only one column. That's why here it is, the notation is D into 1. Fine. And one thing that you need to know, the default vector notation, the default vector notation is basically my column vector. What it means? Let me explain you once again so that you can understand it very well. So let's say what I have told you, for any given flower, we have this flower, for any given flower, we have 4 features or 4 variables. So we are given, let's say, sepal length, sepal width, and petal width. So we have given 4 variables here. And all of them, there are some real values, which means there will be some real numbers here. Likewise, I have told you here, there is some real numbers like this. So this is having some real numbers, real values. Fine. So given any data point like this, we write a data point. Typically, how we can write a data point? For ith data point, we write ith data point as xi belongs to rd. How I can read this? I can read this xi belongs to this rd. And what is this rd? Here xi is a dimensional n-dimensional vector. So a n-dimensional vector is having, I could have this xi as xi1, xi2, xi3, and xid. Fine. So this is a d-dimensional. Since here it is written d, that means if it is written d, that means this vector is having a d-dimensional column vector. And now there is an important thing. This is a d-dimensional column vector, and this is, I'm telling you, this is a column vector. Why this is a column vector? Because here my data point is represented as one column of data. And why this is a column? Because it has d rows and only one column, and hence it is called column vector. I'm calling it a column vector. So whenever we are given a data point which belongs to RD, what it means? The D part here means that it is a d-dimensional column vector. R is, this R here is a basically regular written with, important thing is that if you can see this R is written with two vertical lines, two parallel vertical lines. Fine. And D is written in the exponent part of it. So this is how we represent any d-dimensional column, d-dimensional vector, data vector. Fine. So, and this R is I have told you, this is some real values or values in some real space. So here, each of these xi1, xi2, xi3, and till xid, these all are called components of this vector. This xi is my vector, and these are all called the components of this vector. And each of these components is a real value. That means xi belongs to rd. This is what I mean to say. So if let's say I have, if I have some flower, let's say I am writing f1 is equal to, and I am writing some value 2.1, this is 3.2, this is 1.9, this is, let's say, 4.2. These are my features. Let's say I have a flower f1 which is having these components. So this is, let's say, sepal length. This is my sepal length. This is my petal length. This is my petal width, and this is my petal width. Sepal length, sepal width, and petal width. Likewise, so the 4 features that we have, and when you are not explicitly told what vector it is, see, vector can be a row vector also, or it can be a column vector also. But let's say if you have been not told exclusively or explicitly, you can say, if you have not been told what kind of vector it is, either it is a row vector or column vector, then the default vector notation is always a column vector. If so, that's why I have written this in the form of column vector. This is my column vector. So I have also written here the default vector notation is always a column vector if you have not given anything. And if you are not told anything, the default vector is a column vector. Now, if I say the default vector is a column vector, then it means there is something also called a row vector. That's why I'm talking about the column vector, right? Because without having a row vector, why I will be telling you about this thing. So there is something called a column vector. Sorry, called a row vector also. Fine. Now, what is this row vector? So let's say if you have a data point xi, and let's say I have inside this xi, I have one row of data. This is a row. Let's say I am having this value 2.1. This is having 3.1. This is having, let's say, 4.6. And this is having, let's say, anything 1.9. Let's suppose. So if you look at this data, it is a single row of data. This is a single row. But if you look at this data, the earlier data, there are multiple rows, 1, 2, 3 till D. But if you look at this, here I'm having only single row, only one row is there. But here we are having multiple columns. So this is my first column, this is my second column, this is my third column, and this is my fourth column. So what it means? So the default here also I can write it like xi belongs to this RD. Fine. But here, this is a row vector because I am having one row and 4 columns. We are not having a single column. We are having only one row and 4 columns. So this is the main difference between the row vector and column vector. So I suppose you have understand this, and always remember by default the vectors are represented as, by default notation is a column vector until unless we are exclusively given that this is a row vector or not. So till here, any confusion, anything you want to ask, please tell me, or I shall proceed further.
सर ये सेपल का क्या मतलब होता है?
सेपल का क्या मतलब होता है? कोई भी फ्लावर है तो फ्लावर का क्या है, हम इसको जस्ट एज ए ये ले रहे हैं क्योंकि आगे हम इस हमारे को कोई चीज डेटा सेट चाहिए चीजों को समझने के लिए, इसलिए हम ले रहे हैं आइरिस फ्लावर डेटा सेट। अभी कोई भी आप फ्लावर लेंगे तो उसका 4 फीचर्स होता है जो
नहीं, जैसे पेटल आई नो, बट व्हाट इज सेपल?
जैसे पेटल होता है वैसे
हाँ।
सेपल भी एक फीचर्स है, फ्लावर का एक फीचर है। अगर मैं आपको इंटरनेट, इफ आई विल सर्च ऑन द इंटरनेट, इफ यू जस्ट सर्च the features of the flower, you will see what is this sepal, petal, and all those things. If you want, I can just search on the internet, and can you see my screen? Are you able to see my screen?
Yes, I can see.
Sepal length, sepal length of flower of iris. If I just go here and watch, see, if you just
Petal is this, and what is sepal?
this
Sepal.
This is petal. You can see this is petal. Can you see petal?
पेटल एंड सेपल बोथ आर लुकिंग सेम, इट्स ऑन पेटल पे ही तो है, सेपल ये इधर लिख रहा है ऊपर वाले फ्लावर पे.
But if you will see, there is a difference between petal and sepal.
ओके, दिस
So,
आइरिस versicolor, iris
Virginica and setosa.
setosa and
Iris.
iris virginica.
These are just the classification based on these four features.
Okay,
These are just the four features of a flower.
flower.
Sepal length, sepal width, petal length, and petal width. What I have discussed here. This.
So any flower having four properties, huh?
Yes. The flower is
Every
yes.
flower.
You can classify any flower based on these four features, and based on these four features, you can classify a flower as either a setosa, versicolor, virginica, and one was what was the name of the fourth name?
I'm not able to find it on the internet also. The three names I can see.
Versica, setosa, virginica, and can you see here? If you look, can you see this is sepal length, this is sepal width, this is petal length, and this is petal width.
Oh, so जो petal जिससे connect होता है flower से,
Correct.
that is known as sepal.
Correct, correct.
और उस flower की जो पंखुड़ी है, that is known as petal.
Correct.
ओके ओके. सो पंखुड़ी जो है, मतलब हिंदी में, आई एम स्पीकिंग हिंदी,
हाँ ठीक है ठीक है.
पंखुड़ी जो कनेक्ट होती है फ्लावर के उसके साथ, वो सेपल कहलाता है.
करेक्ट करेक्ट.
जस्ट होल्ड ऑन, स्क्रॉल अप. हाँ, जस्ट होल्ड ऑन. आइरिस सतोसा, वर्जिनिका, आइरिस वर्सिकलर. व्हाट इज fourth one is not there.
Setosa, versicolor, and virginica.
Virginica.
These are the only three. Sorry, these are the only three flowers. Classification is only the three. These are the only three classification.
Okay.
That's why I was confused. This is the only three. There is no fourth one. Setosa, versicolor, and virginica.
Virginica.
Let's say I want to classify only based on these three. Based on these three flowers, these are the categories of the flower. So you can able to classify the flowers according to its features of this sepal length, sepal width, petal length, and petal width. According to these values, you can classify a flower as setosa, versicolor, or virginica. That's all. You got my point?
Got it.
Now, coming to something called as dataset. Let's understand something called as dataset. These are just the basic things. That's why I want to cover it so that you will not face any difficulty in understanding the further ahead. So I will be when I will be talking about this dataset. So I will be always be taking this iris flower as the base dataset to understand, to make you understand a lot of things here. So I will be taking this iris flower dataset. Now let's understand. So what does this dataset? First of all, let's understand. We represent a dataset typically by this capital D. This is one way of representing a dataset, and there are multiple ways, but this is one way. Fine. So dataset is what? Dataset is basically a collection of data points. For, let's say, for example, here if I write a dataset, and let's say this is having some xi points and some yi points, because what I have told you, dataset is a collection of data points. So what does this xi means and what does this yi means? This xi is basically my data points. Data points. And what is this yi? This yi is my class level. Class level. LABELS. Now, to understand this class level, let's go back to this thing. Let's go back to this iris flower. Now, I have shown you I have 3 class of flowers. This is my first class, this is my second class, and this is my third class. So this is my yi basically. And these values, these are my xi's. Based on the values of my xi, I can predict what my yi should be. So this value of xi determines the value of yi. That's why I'm asking, I'm telling you this xi here this xi basically is my data points. And this is my class level. Because based on this data point, if I take the case of iris flower, so based on the value of my xi, and what is my xi? Xi is my features. Sepal length, sepal width, petal length, and petal width. So based on the values of those 4 features, I am able to say which this data or that particular flower having that 4 values belongs to which of the 3 categories of yi, which is my class level. That is here setosa, versicolor, virginica. So
xi is the feature and yi is the category.
Correct. Xi is the features and yi is the basically you can say category, or you can say xi is my data points. Based on that data points, I am able to predict something, and that predicting that value that I want to predict is belongs to one of the 3 classes. And what is my one of the 3 classes? Setosa here in this case.
Virginica and versicolor.
Correct. Setosa, virginica, and versicolor. If I take this 3, so this 3, what the class level will be is based on the value of my xi. I suppose you understood. Now, if I say, since I have told you data set is my data set is basically collection of data points. So this means this data set is having, let's say, contains some n data points. So I can say my I is equal to 1 to I is equal to n. That means my value of my data I is varying from 1 to n. Because, and what is this n? What is this?
It can be any number, I1, I2, I3, up to IN.
Correct. This is something like, I can write it as number of data points. Data points. Fine. Now, basically what I'm saying, let's say I have XA and I have YA. I have certain XA and I have certain YA. So for every XA, there is a YA. I have a corresponding YA. That's what I mean to say. For every XI, I have a certain value of YI. This is basically a classification problem, but I do not want to go into it because that thing we will go discuss in the future. Only point is that if I have some XA, this must have some YA. I have a corresponding YA. And I have n such data points, right? So this n represents the number of data points in my data set. Now, द मोमेंट आई से xi belongs to rd, this rd, what does it means? What do I know from this? This is a d-dimensional vector of real values.
सर
Fine.
ये बार वापस बता दीजिए, समझ नहीं आया।
कौन सा चीज आपको समझ नहीं आया
ये
बताइए।
दैट बिफोर यू हैव सेड
आप हिंदी में बोले, कोई दिक्कत नहीं, हिंदी
आपने
में
डी
बोलिए।
डायमेंशनल वेक्टर बोला था ना अभी, डी डायमेंशनल वेक्टर कॉलम वेक्टर, तो उससे पहले का समझ नहीं
ये
दैट।
ये बोला था।
या ये जो एक्स ए एंड वाई ए है और फिर एक्स आई इज बिलोंगिंग टू आर डी, ये वाला, दैट हाउ इट केम।
देखो आपको इधर आपने इस टाइम पे आप शायद एब्सेंट थे क्या, नहीं थे क्या?
नहीं नहीं, आई वाज देयर ओनली बट
अच्छा ठीक है, मैं यही यहाँ समझाता हूँ। ये देखो, यहाँ पे ये है ना, मैं बताता हूँ आपको। ये एक्स आई बिलोंग्स टू आर डी, आर डी हमारा मतलब रियल वैल्यूज है, और ये
यस
डी रिप्रेजेंट कर रहा है यहाँ डी डायमेंशनल कॉलम वेक्टर। डी डायमेंशनल कॉलम वेक्टर का मतलब, ये देखो 1 है, ये 2 है, अगर ऐसे 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 करके हम ये मेरा फर्स्ट रो है, ये सेकंड थर्ड फोर्थ टिल डी। तो चूंकि इसमें डी नंबर ऑफ रोज हैं और एक ही कॉलम है, तो हम क्या कह रहे हैं, इसको डी डायमेंशनल कॉलम वेक्टर कह रहे हैं। ठीक है,
ओके,
इसको कॉलम वेक्टर में क्यों कह रहा हूं? क्योंकि
इट
There's
हैज
only one
कॉलम।
column.
इसे एक ही कॉलम है, इसमें रो बहुत सारे हैं लेकिन कॉलम एक ही है, दैट्स व्हाई आई एम कॉलिंग इट एज कॉलम वेक्टर। इसका उल्टा हम यहाँ पे बात कर रहे हैं रो वेक्टर। इसमें क्या है, रो एक ही है लेकिन कॉलम अलग अलग है, मतलब मल्टीपल कॉलम। यहां मैंने 4 कॉलम लिए हैं, 4 से ज्यादा भी हो सकते हैं। तो यहाँ क्या हो रहा है कि एक रो है और 4 कॉलम है। इसको अगर मैं यहाँ लिखूं तो मैं क्या करूंगा, हम जब भी कोई डेटा मैट्रिक्स बनाते हैं तो रो इनटू कॉलम होता है, ये पता है आपको।
यस
ठीक है,
यस।
यहाँ पे हमने क्या लिखा, डी। तो डी का मतलब क्या है, डी
डी
रो,
डायमेंशनल
Dimension.
डी रो,
कॉलम वेक्टर।
मतलब डी का मतलब डी रो,
Row.
और 1 का मतलब 1 कॉलम।
हाँ
करेक्ट।
हाँ.
अब यहाँ पे अगर मैं यही सेम चीज को करूं तो यहाँ पे एक बात
One
बता,
multiply by D.
तो यहाँ पे रो कितना है हमारा,
One.
So is one and
कॉलम कितना है,
columns are D that dimensional column.
4। यहाँ इस
Okay,
केस में 4,
columns are four.
हाँ. One multiply by 4.
1 मल्टीप्लाई 4। समझ में आई है? अब
Yes sir.
इसी चीज का एक्सटेंशन हम यहां समझते हैं। यहां पे मैंने बोला कि ये एक हमारे पास एक डेटा सेट है, ठीक है, जिसके पास एक्स आई है और वाई आई है। एक्स आई मेरा डेटा पॉइंट्स है, ठीक है, और बेस्ड ऑन द वैल्यू ऑफ एक्स आई मैं ये पता करूंगा कि मेरा वाई आई क्या होगा। अब वाई आई को मैंने बोला ये क्लास लेवल है, और इस क्लास लेवल का 3 क्लासिफिकेशन है, 3 वैल्यूज हो सकता है, या तो ये सेटोसा हो सकता है, या तो वर्सिकलर हो सकता है, या वर्जिनिका हो सकता है। ये तीनों में से कोई एक हो सकता है, बट इन तीनों में से कोई एक कौन सा एक होगा, ये मेरा डिपेंड करता है
X I by.
एक्स के वैल्यू पे। एक्स के वैल्यू के हिसाब से ऑलरेडी ये डिफाइंड है कि बेस्ड ऑन द वैल्यूज ऑफ एक्स। अब एक्स क्या है हमारा, एक्स डेटा पॉइंट है। अब यहाँ पे अगर आप देखोगे तो मैंने ये यहाँ पे डिस्कस किया था पहले ही, एक्स हमारा यहाँ पे है सेटोसा, वर्स सॉरी,
नहीं नहीं नहीं. Sepal length. Sepal length. Sepal
पेटल
width.
लेंथ
Petal
एंड
length.
पेटल,
Petal width.
इन सब के वैल्यूज के ऊपर डिपेंड करता है हमारा वाई क्या होगा। ठीक है, तो मैंने ये सिंपली यहां लिखा एक्स आई बिलोंग्स टू आर डी। इसका मतलब क्या हुआ, इस केस के अंदर अगर यहां पे मैं लू, अगर मैं लिखूं एक्स आई बिलोंग्स टू आर डी, तो इसका मतलब क्या हुआ, अब मैं आपको बताता हूं। इसका मतलब ये हुआ, ये जो एक्स आई है, मैं ऐसे लिख सकता हूं एक्स आई बिलोंग्स टू आर डी 4। डी के जगह मैं 4 लिख सकता हूं। क्यों लिख सकता हूं,
4 column है.
कि 4 डायमेंशनल वेक्टर है। वाई 4 डायमेंशनल वेक्टर है क्योंकि
वो
एक्स
कॉलम है और
बाय डिफॉल्ट दिस इज, एंड वाई आई, यहाँ पे एक्स आई हमारा क्या है, एक्स आई हमारा आपको भी पता है एक्स आई हमारा क्या है?
सेपल लेंथ, पेटल लेंथ,
सेपल
सेपल
लेंथ,
विड्थ,
पेटल लेंथ,
पेटल विड्थ और सेपल विड्थ।
पेटल, सेपल लेंथ, पेटल लेंथ, सेपल विड्थ एंड
पेटल विड्थ।
ये है। और
हम्म।
वाई हमारा क्या है? वाई हमारा है,
वर्जीनिका, सटोसा और
करेक्ट,
वर्सिकलर।
सेटोसा, सेटोसा, वर्सिकलर,
वर्जिनिका।
वर्सिकलर और ये वर्जिनिका।
हम्म।
ठीक है। तो अगर मैं इसको वेक्टर के फॉर्म में रिप्रेजेंट करूं, डेटा वेक्टर के फॉर्म में, तो कुछ इस तरह से नहीं होगा। अगर ये मेरा एक्स है, लेट मी इसको थोड़ा सा छोटा कर देता हूं, सही है। अभी मैंने बोला एक्स आई और ये वाई है, करेक्ट।
हम्म।
मैं एक्स आई को ऐसे लिख सकता हूं, बाय डिफॉल्ट। मैंने आपको बोला बाय डिफॉल्ट अगर गिवन नहीं है तो कोई भी
फोर
वेक्टर,
रेज आ जाए, फोर रोज आ जाएंगे।
वेक्टर। तो ये हम इसको सेपल लेंथ, सेपल विड्थ,
हम्म।
पेटल लेंथ,
पेटल।
सॉरी, पेटल विड्थ, पेटल लेंथ एंड पेटल विड्थ लिख सकते हैं। दिस
हम्म।
इज माय एक्स आई।
हम्म।
एंड वाई 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 आई को मैं ऐसा लिख सकता हूँ,
रो में जाएगा सेटोसा,
सेटोसा, टोसा,
वर्सिकलर,
वर्सिकलर,
वर्जिनिका।
वर्जिनिका।
हम्म।
मतलब ये रो, ये मैं क्लासिफिकेशन कर रहा हूं कि इनमें से इनकी, इन चारों की वैल्यूज के ऊपर डिपेंड करता है कि
वाई
ये
क्या
जो
होगा।
भी कोई डेटा पॉइंट होगा, कोई एक फ्लावर होगा, मैंने एक फ्लावर लिया, अब उस फ्लावर के ये चारों वैल्यूज मैंने निकाले। अब जब मैं चारों वैल्यूज निकाल लिया, तो उन वैल्यू के ऊपर ऑलरेडी ये डिफाइंड है कि अगर वो वैल्यू किस किस रेंज में फॉल करेगा, तो हम उससे डिसाइड कर सकते हैं कि हमारा वाई आई क्या होगा। या तो ये सेटोसा होगा, या तो वर्सी कलर होगा, या तो वर्जिनिका होगा। तो ये एक तरीका है डेटा सेट को रिप्रेजेंट करने का। ठीक है।
हम्म।
तो अभी आपको ये समझ में आ गया। और मैंने
यस।
ये बोला यहाँ पे ये चीज कि एक चीज, ये एक्स आई क्या है हमारा? डेटा पॉइंट है,
वाई क्लास लेवल है।
ये क्लास है। ये समझ में आया? ठीक है। तो एक चीज इसमें बहुत इंपॉर्टेंट चीज जो है वो हमको याद रखना है, वो ये याद रखना है कि अगर हमको दिया नहीं हुआ है, इफ आई एम नॉट गिवन, तो डिफॉल्ट रिप्रेजेंटेशन मैंने आपको पहले भी बताया,
कॉलम वेक्टर।
कॉलम।
कॉलम वेक्टर।
मिस्टर राकेश, आपको कुछ समझ आ रहा है ये चीजें जो आज हम डिस्कस कर रहे हैं? आप अनम्यूट कर सकते हैं, वो बात कर सकते हैं। तो आज, आज के लिए अभी टाइम कितना हो गया? इट्स गोइंग टू बी 11:25। तो आज के लिए इतना ही रहेगा। नेक्स्ट हम इसके आगे डिस्कस करेंगे नेक्स्ट सेशन में। और मैं कोशिश करूंगा, और आप लोग ऑनेस्ट फीडबैक मेरे को दे, और उसमें कोई शर्मा नहीं, कि सो दैट आई कैन ऑल्सो इम्प्रूव। मैं चीज़ों को थोड़ा कोशिश करूंगा कि क्या बेटर तरीके से आपको मैं समझा सकता हूँ। तो मैं इस चीज़ का कोशिश करूँगा। ठीक है। तो अभी मैं अपना स्क्रीन शेयरिंग बंद करता हूँ। और ये भी मैं सीट्स, रुकिए, मैं ये सीट आपको दे ही देता हूँ, सो दैट यू कैन हैव। एक सेकेंड आप रुक जाए। एक्सपोर्ट ऑल, तो आप अभी डाउनलोड कर लेंगे, आपके पास मिल जाएगा। लेट मी गिव इट टू यू। ठीक है। जो भी मैंने आज डिस्कस किया है, वो इसके अंदर उस आप एक बार इस पीडीएफ को खोलिए जो मैंने अभी आपको चैट बॉक्स में दिया है। ये कुछ,
रिसीव्ड।
हाँ,
रिसीव्ड।
एक बार उसको आप खोल के देखिए कि कुछ दिख रहा है या ब्लैंक है।
नहीं दिख रहा है, फर्स्ट 3 स्लाइड्स जो है ना वो ब्लैक बोर्ड ही है। आपका फोर्थ से स्टार्ट हुआ है।
ओके।
यू
ओ,
स्टार्टेड योर रिकॉर्डिंग।
अच्छा।
राइटिंग
तो
जो
मैं
आपने
देख
बात।
रहा हूँ ये यार ब्लैंक है, ये तो कुछ लिखा ही नहीं है इसमें। हाँ हाँ हाँ, अब मेरे को भी दिख रहा है। ठीक है।
हम्म।
तो राकेश जी, आपको कोई आज का तो हम ये खत्म कर चुके हैं अभी। इसके बाद कुछ ये नहीं है ऐसा। तो हम अगर लोग इसको डाउनलोड कर लीजिए।